So the reason for me to talk about this is that I feel strongly that we are not doing enough. We as humanity, we are not doing enough to solve problems with machine learning or with AI. AI is just shorter, but when I say AI, I really mean machine learning here. And it's really tragic. It's really a pity that we don't do more, because as you will see in this presentation, the technology gives you so much leverage, gives you so much reach to solve real problems that it's just embarrassing that we are not using it more. So I'm going to tell you more. Can you click next, Nico? I'm going to tell you more about how we choose projects, what I've learned in 165 projects that I've mentored. But just for an introduction, and I'm pretty sure you guys noticed that the world is very different now compared to how it was even 3 months ago, right? And I think this is going to be really interesting times for many. It's not looking too good. Can you click next, people? So for a while, this is how different the world is now, right? For a while, the price of oil was negative, right? And it seems to have recovered very fast. Nobody would have expected recovery this fast. I mean, we are seeing things right now in the market that would have looked ridiculous if we were talking about cryptocurrencies, right? Everybody was joking about cryptocurrency markets doing crazy things, but what the real markets are doing right now is even crazier, right? So if somebody told you 5 years ago that the price of oil will be negative, you will laugh your ass off, right? So this is happening right now. Banks are doing all kind of crazy things as well. Money is being thrown in helicopters for businesses and for people who are getting paid more as unemployed people as they were when they were working. And basically, jobs are disappearing left and right in front of you. And some of these jobs are never going to come back. They're going to be replaced by other jobs. And the fact that this is happening, as scary as it may look, I think it's an opportunity for probably everybody in this room, in this virtual room, because companies are going full force into digitalization. Companies that were before moving very slowly in terms of digitalization, they had to jump head first, and they realized in the last month or two that they could have a mostly remote staff that is doing pretty much the same things, and that produces a lot of data, and that data must be analyzed by somebody, right? And somebody is you in this room, right? Somebody is all the data scientists in the world that are trying to break into the field, and that they're looking for an opportunity to prove what they can do, right? So if anything, it could be that Corona times are going to be overall horrible, but maybe not so bad for data scientists, because there is just so much more data now than there was before. So although things look pretty terrible, I think Germany is doing better than mostly anybody else. And this is a good thing. So I was not very positive about Germany and Europe before, and now I am. So this is, for me personally, very pleasant, because I am in a country where I trust we're going to do well. And in general, it should be a good feeling for everybody who is already in Germany. But even if you are not, if you are watching this from some other country in Europe, there are many things that you could do. So if you are in Spain or Italy or Poland or Portugal, you know that your economy is going to be really tanking, or already is. So I'm going to tell you something about what to do if I were you towards the end of the talk. So just as a quick intro, I've been doing machine learning for a long time. I actually don't know how long, probably more than 15 years now. I have a PhD in machine learning from the US. I've started a few companies, and I always bootstrapped so far, so I never took investment. I've been mentoring portfolio projects for the last 6 years that my company, Data Science Retreat, has been around. And because I've been doing this, I had to develop a sense of what projects will work and what projects will not be easy to pull through. And this is exactly what I think is the most valuable thing that I can contribute, basically, and the reason I'm doing this talk. So if you stick with me for the next 40 minutes or so, you will learn about what things we have tried, what things have worked well, and what things have failed. And maybe if you say, well, I'm not so technical, so I actually don't care about technical details of projects, that's actually quite okay. So what we're going to hear about is what projects are doable with current machine learning technology. And you will see some examples of problems you can solve with existing off-the-shelf technology that you would not have considered solvable before. So if nothing else, I hope that I convince you in this talk that many problems that are supposed to be very hard can be solved with off-the-shelf technology. And let's talk to just start with one single problem. This is Masanori. He's an alumni of Data Science Retreat. He came from Japan because people come from all over the world. There's like ridiculous diversity. He came from Japan to Berlin to do our 3 months 3 months course in machine learning, and he looked at the sidewalk. Sorry, I'm reading the comments that people are posting, so I kind of get frozen, so I'm going to try not to do that. So Masanori landed the plane from Japan, stood out of the plane and thought, oh, wow, the sidewalks in Berlin look terrible for wheelchair users. So I was a volunteer pushing wheelchair users in Japan, so I know that these rocks that we have here are very unpleasant for wheelchair users. How can I help them? How can I help them go from one point to another in the smoothest way possible? Next. So what he did is, okay, let's see if I can film the floor, the sidewalks of Berlin with a real wheelchair with phones mounted on its arms so that you are recording the floor as you move. And at the same time, you will record the vibrations of the phones, right? The phones have accelerometers, so you can record the vibrations. Can you click on the video, Nico? And this is what he did. He went around and using first the wheelchair and then extrapolating to the entire city of Berlin using Google Street View, which is the data that you're looking at right now. This is how he just filmed the floors, the sidewalks in Berlin. This is around our office. Can you click next? Yeah. And then these are the results. So what he did was doing segmentation. As you can see, the image is colored differently. So the green stuff is super smooth. The red stuff is not so smooth, right? And the blue is kind of okay. So with this data, any picture of the sidewalks in Berlin gets identified like this. So with this data, he could have a layout on OpenStreetMaps, and then he could recommend a wheelchair user or a skater or somebody with small wheels, like pushing a suitcase, for example, how to go from point A to B in the smoothest way possible. So one thing that you can see here is that this is a real problem, right? There is a big chunk of the population that is on a wheelchair right now, and they would like to go places, but they don't know if this is going to be a smooth path for them. So with this technology, you solve a real problem for real people, right? And this problem was solved in less than 3 months, right? So people come to us for 3 months, but they only work on their projects for maybe half of that time or less. So there is real technology off the shelf that you can pick and start running like this. So for sure, the technology didn't know what you wanted to do, didn't know that you wanted to do sidewalks, but it's totally doable to do in a very short time, to tweak a model so that it recognizes sidewalks. And this works for Berlin only right now, but it could work for any other city. Just a matter of training it with other Google Street View images. So this is an example of what I'm trying to communicate here in this talk. You can, with some effort, but not much, from the kitchen table of your home in your underpants, and write software that solves real problems for real people with machine learning. And this is very surprising. This is something that nobody expected. So nobody expects the Spanish Inquisition, right? So nobody expected 5 years ago that anybody could just pick up a library, train a model in a short time, and solve a problem like this. So this is one of the things I love about being in machine learning. It's a field that proves you every 6 months or so that what you thought was impossible is now possible. Can you click next, Nico? Right. So the presentation is going to go through everything that I've learned in the last 6 years about how to do problems like this, like solving real problems, how to do projects that solve real problems. And I'm going to structure the presentation into finding the problem, collecting the data, working the data, and modeling. And each of these topics will have a different color for the slides. Next, yeah. So the first thing that I've learned about picking problems is that you don't need that much data at all. So there is this myth that you need to be Google. You need to have petabytes of data and servers full of GPUs to do anything worthwhile. This is simply not true. And I don't know if it's actually the intention of Google to make you believe that you need all that much so that you don't do it. By you, I mean companies, right? But the truth, in my experience, is that people here at TSR come and pick problems and pick up data and run the models pretty much either on their laptops or on a cheap instance of Amazon Cloud, also Google Cloud. So first things to consider is that when you think about picking up a project, don't think that the project is out of reach and that you need to be Google to solve it. You can get value out of machine learning with very little. Again, remember this image of yourself sitting in your kitchen table in your underpants and solving a real problem. This is totally doable, right? Okay, second thing that I've learned, there is so much spectacular stuff that you can solve right now that you should test your idea against people and look at their eyebrows. Nick, when you click next, when you tell your problem, the problem that you're solving to people, they should do this. Can you click next, Nico? So if you don't get this expression on their face, don't do the project. It's totally doable to do nowadays projects that make people raise their eyebrows. If they don't raise their eyebrows, don't do it. There are plenty of problems that you can do that will raise their eyebrows, right? Okay. This is one I love. You don't need to pick a project that is perfect from the beginning. Sometimes you only need to be in the ballpark of a good idea. And this idea will become obvious to you at some point later. Next, Nico. So this is the way I like, back. This is the way I like to think about it. Sometimes you are moving in a low visibility environment, like a radar in a submarine, or whatever it's called, sonar, and you see a dot, but you only see it when the radar part of it is passing by, right? But then if you move towards that dot that is blinking, you see more of it, you get more resolution, right? this is what I think you should do with problems. I'm going to give you an example. There was a team, Nico, don't move yet. There was a team that didn't know what they wanted to do. So individually, they came to me and said, I don't have an idea. I don't know what to do. I'm stuck. So then I asked this team, one person of the team, okay, what moves you? What is something that you really like? And he said, you know what? I hate when there's waste, when people throw away things, or when trash is not useful. And then I said, okay, let's work with that. Let's see what we can do with recognizing trash and so on. So we found a project by a Stanford graduate that has some way to recognize trash into plastic, paper, and so on. That was good. That was something interesting. That's something that you can do with machine learning for sure. And then some other person came to me with the same problem. Oh, I don't know what to do. I'm good at iterating on ideas, but not so good at coming up with ideas myself. So I'm stuck. So talking to this person, we kind of joked that it would be great if you could have Wall-E, the robot from the movie from Pixar, going around and picking up trash for you, right? So that was already something that you could combine with the idea of recognizing trash, right? So then these two guys made a team together, and then a third person joined, and they iterated on this idea. So remember this idea of the radar going around and doing pings, right? So it turns out that they could potentially build something like Wall-E that would pick up trash. How? By taking a project from a previous batch of TSR that was doing a toy self-driving car. So that was also a super cool project. So they will just assemble something on top of that car, like a like robotic arm that will pick up trash, right? So boom, with that you have something that sounds much stronger. You can actually build Wall-E. So it's not going to be as cute for sure. The car that you will see later was kind of ugly, made of wood and wires and so on. But the idea was there. And so that's kind of getting closer to an idea that would be making people raise their eyebrows, right? And then one of them said, okay, but how about we don't do all type of trash? That's kind of easy. Why don't we do the most pernicious trash that there is, cigarette butts? Cigarette butts, I don't know if you guys know, but they're very bad for the environment. One cigarette butt can contaminate 40 liters of water, and they're very hard to pick. So they're so light that all the machines we have, they just move them around, but they don't really pick them. And if you try to do it with a broom, it's just so difficult to get them, right? So this toy self-driving car will go around and pick up cigarette butts. So that is a kick-ass idea that will make people go up with eyebrows. And this didn't happen all at once. It was a tiny little ping on a radar that became more intense as you will navigate towards it, right? Okay, next, Nico. Right, so then one thing that you may have picked up from that example is one other recommendation that I have for you guys is that you should pick a problem that moves you. And it's better yet if you are part of the target group, you have that problem yourself. That is going to save you a lot of trouble. For example, if somebody will ask me to solve problems for golfers, I will probably put together a product that is not that useful for golfers because I don't know anything about golf, right? I don't know what is a problem for them. I don't feel identified with that. It doesn't do anything for me. So I will just go through the motions and I will miss many good opportunities to solve real problems for golfers because I'm not one. Now, I'm a data scientist, so I can see problems for data scientists. I've been in their shoes before, so I had to teach myself pretty complicated stuff back in the day when there were no video tutorials and not so many papers and not so much open source code. And I know how this to be there, so I can come up with things that help people become a data scientist faster in a less painful way. So this is my recommendation to you. Pick a problem that you already have, or at least a problem that moves you. In the case of the wheelchair example, Masanori was a wheelchair volunteer pushing people in wheelchairs. So this is something that motivated him, right? If you do that, you will have first more tools to think about the problem because you experience the problem yourself. Second, more motivation. You probably will stay up longer thinking about the problem. And third, you will make people happy that are people that you already met, people that are close to you. So my recommendation is pick a problem that moves you. Next, Nico. And now you may say, well, I don't have any problems. So it could be that you cannot come up with problems that you have or that anybody has that you know. So I've been there multiple times. Next, Nico. The truth is that I don't believe you. I don't think you don't have any problems that you can solve with machine learning. You need to think about what those problems are. But okay, let's assume that you cannot do that. You cannot come up with any problem that you have. Then I recommend you to go to a place where people bitch about their problems. This is a gold mine for you. So one way to think about this is safaris. People go to a safari to take photos of animals, right? You can go to anywhere in the savannah and just sit there with your camera and hope for an animal to show up. But it's much easier if you go to a water hole when they have to go to drink. You know that every animal needs to drink at some point. So the likelihood of catching animals, so animals for us are problems, right, is to go to watering hole. So what are watering holes in reality? Next, Nico. So for us, these are places online where people go to talk about their problems. So Reddit, Twitter, an actual water cooler, or some obscure forum, these are places where you will see people bitching about their problems. The more they bitch, the deeper the problem is for them, and the bigger the opportunity for you to solve the problem. I took this idea from Amy Hoy, who's a person working with startups. So watering holes are perfect places to come up with ideas for your next AI project. And the more people bitch about the problem, the more they're going to like your solution. Next, Nico. Okay, so imagine that you are not in a position to pick up problems. Imagine that you work for a corporate and they basically will never hear you if you find a problem, right? So then what can you do? Well, just take this presentation and throw it the way of somebody who can, because you may not be able to pick problems, but you may influence somebody that can pick problems. And this is, all things equal, this is the best thing you can do, to just get somebody else to pick a problem and maybe convince them that the problem is worth picking. Next. Okay, so this is pretty much all I have for picking problems, right? Now let's talk about data collection. So many times you hear people complain that there is not enough data, that all the good data is taken or is private, and data is either private and valuable or public and crap. I've heard of this. I don't believe it. I think there's so much data out there that you just don't want to believe how much data is available right now, openly. So first of all, there are APIs that you can just plug, and you can pick different APIs. There is a website, I think it's called Read Write Web. I don't know if it's still around. There are websites that just collect APIs. So they make a list of all the sources that you can use. These APIs, I mean, they may be brittle, they may not be ideal, they may change without telling you and so on. So it's not ideal, but you can have APIs for all kind of crazy stuff. So imagine that you want to know, I don't know, how many McDonald's burgers are sold in any place in the world. I'm not sure, but maybe there's an API for that. There are APIs for all kind of crazy things. And if you plug multiple of those together, even if you don't do any machine learning, just combining different sources of data, this is very powerful. This will make you able to answer questions that nobody else could answer before. So imagine that you have data about parking spots that your city provides and data about something else, the foot traffic in front of some shops, and I don't know, some other data point like the prices of something that changes price, I don't know. Then you can put these three things together and make an app for people to get the cheapest X and be able to park near of where this X thing is. I'm just improvising here. I didn't have this sample prepared, right? But my point here is that you need to put together three data sources that were never put together before. And this gives you an advantage already. Next, Nicole. Okay, and then even better, you can create data that you own. You may say, well, how am I going to create data, right? So data is supposed to be very costly and you need lots of it. Okay, I have one hack. Just use cheap hardware. It's funny how many things you can buy from the equivalent of eBay in China. What's this called? First name? AliExpress. AliExpress is kind of like Amazon, but in China, and they have all kind of crazy hardware, like bits and pieces, not finished products, but bits and pieces that will let you buy things that are ridiculously cool for very cheap. For example, you can buy a microscope, you can buy a spectrogram, you can buy lasers, you can buy accelerometers, and all these things you can attach to a phone, to a computer, to a drone. You can also buy a drone, and you can assemble this with duct tape. You can have a cheap phone attached to a drone. In this case, it must be a big one, attached to a camera, attached to a telescopic lens or something like that, and you have a ridiculous amount of data you can collect with that. Mind you, it may not be legal because I don't think it's allowed to just film people on the street with your drone. But you can also attach a microscope to a phone or a spectrogram, and spectrographer, I think it's called, basically a sensor that will give you information about the materials something is made of. Okay, so I have one other interesting example for you guys. Okay, back in the day, 2 years ago or so, I had an au pair, and she came home one night, well, actually one morning on Sunday, saying, I don't know where I've been, I don't know what I've done tonight, I don't have my bag with me, I don't have my phone with me, I don't remember anything. And we thought, well, this is probably a roofie. Somebody put something in your drink, and let's hope nothing happened to you. So we took her to the hospital. She was not raped, lucky for everybody. But this bothered me, right? So I thought, what could we do to avoid this? Okay, so luckily there were two people at DSR with a PhD in chemistry and biology who were doing work with this type of spectrographers. So they bought a sensor from AliExpress for $70 that is small enough so you can attach it to a phone on the back of the phone, and an LED light that makes it such that you can point this to any material, any object, and it will tell you what it's made of. So they told me that you can detect whether chicken is rotting, whether some food has peanuts, and so on and so forth. But more importantly, if you point it to a drink with rufus on it, it should be able to tell you that there is rufus on it. And this will solve the problem of my au pair, right? So imagine that anybody will be able to carry on their back a phone attachment that will let you scan your drink. That would be fantastic, right? Okay, so we didn't do it for one reason, and maybe you are thinking about this already. If we do this, well, remember you can use the same tool to scan, say, cocaine or, I don't know, any of the other drugs that people take. I don't do drugs, so I don't really know so much, all right? And it will stop you. It will say, hey, if I were you, I will not put this into your body right now because it's being cut and it has all kind of stuff that is not the drug that you think you're taking. So it will prevent people from going into a coma, for example, right? So pretty useful piece of technology, lots of data that you can do, you can use. And the key here was to use hardware that didn't exist before. So you have a phone, and you have a piece of hardware that costs you next to nothing. All right, so why did we not do this? Okay, imagine that you are the drug lord or the drug kingpin in Berlin, and you hear that this tool exists. So next thing we know is that they will, like the equivalent of Pablo Escobar with a shotgun, will be at our door doing like shh, shh. And we didn't want that to happen, so we didn't do the project. Well, there were technical reasons also. It was not that easy. So they actually gave it a good push, and it was not so easy. But it's pretty, yeah. And Filippo is actually one of the two members of the team that went for this. Could be here right now. I just saw in a comment his name. So I hope he's here and he talks to us later about this project and how they decided not to go for it and so on. Okay, next, Nico. Okay, so this is Eduardo. Eduardo woke up one day and realized that he could build a tool that runs on a phone that will be able to detect malaria by itself without any human intervention. And it must be a very good feeling to wake up and realize that if you push this through, if you put this in production, you could save 600,000 lives per year. Because it just happens that in the places where there is malaria, they don't have doctors. They don't have that many doctors, right? And for doctors, the way they do malaria right now, can you click next, Nico? Is to just count parasites by hand. Like they look through a microscope, they count these little kind of rings that you see there. And if there's a concentration of X number per square centimeter or whatever, then they declare that the person has malaria, right? This is something that machine learning can do today. So Eduardo did push through the project quite a lot. He spent 8 months doing only this. He talked to all kind of NGOs. He got funded in a project similar to Kickstarter. He went to the Amazon River to collect more malaria samples, and then talked to many hospitals around the world to get as many malaria samples as he could get. And I think he has now more malaria samples than any hospital on Earth, which is not too hard, honestly, because they don't take photos of them most of the time. So this is a project that is still alive, and if you want to talk to him, just contact me or contact him at aiscope.net. So this is an example of how much leverage you have with machine learning. So I keep saying this, and it sounds like I'm hyping it up, right? So in my view, machine learning is actually underhyped, if anything. So the things that you could be doing with machine learning right now, and the things that we are doing, they are just not the same. There's so much low-hanging fruit. This is my belief. Why we are not doing more? I don't know. But I want to do anything in my power to make sure that we humans do more of this. I answered the question about the API website. I think it's readwriteweb.com. Or no, programmable web. Yeah. So Eduardo, you can. I have his email, but I don't know it from the top of my head. Okay. Next. Here's a photo of the first prototype. Yeah, programmable web. Perfect. Thank you, Vincenzo. So this is the first prototype of the malaria microscope. If you see that little phone that he has on his table and the thing that is on top, exactly, AI scope, perfect. This is the first prototype. This is an USB microscope that was supposed to produce 1000x, but it was not so easy. It took some hacking to get to 1000x. Next, Nico. Okay, so this is another recommendation. Go for a project that has a gold standard. More so if you are already inside a company, you have to convince somebody to give you time or money or team members to do your project. Don't do a project where it's hard to demonstrate improvement. For example, if you do a recommender system, you can go to your boss and say, look, boss, this is the top 10 recommendations for item X. Do you like them? I think it's an improvement. And your boss will say, well, I don't think it's an improvement. The previous top 10 results were as good. And you know, he has a point. It's very hard to demonstrate improvement in unsupervised learning or recommenders. It's far easier to do supervised learning. Imagine that you are detecting cats and dogs. You go to your boss and say, okay, boss, this machine can classify dogs with 97% accuracy. And then he will just go through some pictures and go like dog, not dog. Okay, yeah, I believe you. And you say that the accuracy is 97%. That is very good. Here is more runway. Here's more team members, more money, more time. Very important to have a gold standard. Right? Next, Nico. Right. So then, to have a gold standard, you need to find what to measure. And this is the book that I recommend everybody about how to measure things. It's surprisingly difficult to measure things, but most people in statistics and judgment theory and so on have some pretty actionable results. And this book is pretty good at that. So when somebody tells you, well, I don't know how to improve X because I don't know how to measure it, just throw this book at them because it's going to help them. Right. All right. So another hack to do projects that raise eyebrows is to use multiple models doing a single task. So doing something spectacular with one single model is hard, right? Many things are already done. But you can combine multiple models that each of them does one thing well. Next, Nico. And one example is this self-driving toy car. This is how it looks like here in this photo. It was called Emily. So Emily is a toy car, and it's pretty like hacky. As you can see, it's made of wood. So Emily is one project. It's a car that it's a toy car, moves around, that drives around, and can go places. That's project number one. That's challenging in itself. It was done by Marcus, somebody who graduated like 2 or 3 batches before the rest of the team. Yeah, it's a Raspberry Pi. It was a Raspberry Pi, and then we discovered NVIDIA Jetson. So NVIDIA Jetson, it's similar to Raspberry Pi, but it has a GPU. And for this type of computation, and GPU is really wonderful. So now, project number 2 is you need to be able to drive to where the cigarette butts are. So you need to identify the cigarette butts on the floor and go to them. That's project number 2, model number 2. Model number 3, you need to pick up the cigarette butt. So there was a robotic arm that would just go and stab the cigarette butt. And that's completely a different model. You can work on this in isolation. You can do it on a table. Just put a cigarette butt and try to stab it with a robotic arm, which was kind of complicated enough. Now the 3 things together, 3 projects together, 3 models, create something new that goes around. And imagine that you are in a park, you are in our park, and you can see the cigarette butts there, right? What if at night you will have, well, maybe not at night because they need vision, right? But sometime during the day, you will see a swarm of these cars going around and picking up cigarette butts. That would be so much more convenient rather than having to lay down and hit a cigarette butt next to where you're putting your cheek, right? So, the Raspberry Pi with a GPU is called NVIDIA Jetson, like the Jetson family. Okay, next, Nico. Right. So one other thing is that people suspect that you need a lot of data to train a model, so that is any good at all. In my experience, that is not the case. You can do a lot with what I call a minimum viable corpus, and you can bootstrap a bigger corpus. So once you have enough recognition capability for the self-driving toy car to pick up or to identify some cigarette butts, then you can let it roam around and find more cigarette butts, and then you have a bigger corpus of photos of cigarette butts, right? So I have an example next. There's a company that I really like called Blue River. So what these guys do is they build a machine that sprays plants that have bags on them, but only those that have the bags, not the entire field. As you can imagine, that saves a lot of how do you call the thing that kills the bugs?
Pesticide.
Okay. Say it again. Pesticide, exactly. Yeah, pesticide. So I had a tip of the tongue phenomenon. Pesticide. So what these guys did is pretty amazing. They were, imagine these 5 guys, right? Going down, let's say a potato field. I don't know what those plants are. And with their phones, with their phones, they were taking photos of the plants and creating a corpus of data for their model to be trained. Can you hear me? Yeah. All right. So we're going to go a little bit faster. So this is really literally 5 people going down a potato field, collecting enough data. Next, collecting enough data to build a model that does this. They will recognize plants. This is a 3D image of a plant. And then they can build this thing that the tractor has to spray only the plants that have the bags. And they got bought by John Deere for, I don't know, something like 300 million, something serious. And that's a beautiful story of how you can start with very little data. Basically, you going down a potato field with a phone, taking pictures, and building something really useful. Next, Nico. Right. So VCs like to talk about modes and about building network effects with data. So if you have more data, you will do better. Next, Nico. Well, that's not always true. So having more data costs you more money, costs you effort, processing time, and sometimes it doesn't help. So this is a graph about collecting data for a chatbot that does technical support. So the x-axis is how much effort it takes to do data collection and processing, and the y-axis is the intent coverage. So it's how many sentences you can understand and answer. As you can see, it plateaus very fast. You can still spend a lot of time and money and CPU power collecting data, but the the thing that the coverage is plateauing very fast. So there are not that many places where you can get data network effects as PCs love to have. Next, Nico. Right. Okay, this is something about data collection that I realized. We are in the EU, right? We love our privacy. We have very strong laws against taking people's data and putting them in a centralized place. There is a way to collect data, but not moving it to a central server, and that is doing edge computing. Sorry. Nico, can you click next? And this is the best resource that you can find about edge computing. Andrew Trask is a very good guy to follow in this. He's working for DeepMind right now and doing a PhD at Oxford. He has a Jupyter notebook with all kinds of examples that will help you understanding computing at the edge. And he also has this Udacity course that I recommend. This is very handy if you want to collect data and you don't want to have any kind of problems with privacy. So another hack, use edge computing for your models. Next, Nico. Right. This is a little bit obvious now after what you've heard so far. Think in terms of sensors. You have a phone has a camera, and it has an accelerometer, and it has maybe some other sensors that are not so common. Maybe it has a flash that could do something for you. In fact, you can detect somebody's pulse by asking them to put their finger covering the flashlight and then flash it so you can see the blood with the camera and the light of the flash. Okay, so flash is another sensor, let's say, right? Or helps the camera sensor. But as I told you, you can buy all kind of crazy sensors off basically a Chinese platform, right? Like AliExpress. What I want to say here is think in terms of sensors. There are cheap sensors that you can attach to a phone or a computer or a drone or toy self-driving car that will do things for you. Think in terms of sensors. Next. Another way to collect data and work with data that not that many people can access is to do partnerships. So if you get a partner that will give you data, this is a very good way, and more so if you have multiple partners, very good way to have a project that will raise eyebrows. Now there's a catch here, which is if your partner at some point doesn't want to give you data anymore, then you're dead in the water. So it's kind of scary to build a business around some data that you don't control, which is often the case. So if you do data partnerships, make sure that your partners are not going to leave you hanging later. Next, Nico. Okay, this is a big one. When people think about data, when I say people, I mean companies. Companies think about tables, tabular data. That is the most common source of data, the most common format, or was the most common format so far. Now we are at the age where you can do unstructured data. Unstructured data is images, video, sound, text. This is a lot more data, but only now, only in the last 5-10 years, we humans are able to run models that take this data as input. Next, Nico. And data, and unstructured data, for example, video, can you click here? Has made incredible progress. Look at this. Let's exit the video. Okay, so this is YOLO. This is a image segmentation tool that you can run on one computer off the shelf, and it will do what you just saw. Identify identify objects in a very chaotic real-life situation and track where these objects are going it can identify, I don't know, 10,000 classes of objects, including people, and it can track them while they are moving. So this is ridiculously powerful. This means machines can see. If a machine can identify 10,000 objects as they move, that is a machine that can see. What can you build with machines that can see? And this is literally off the shelf. You can go to a shop, buy a computer, download this software, put it in your computer. It must have a GPU though. So buy one of these ugly gamer computers and have this in your living room or in your company. What can you do with a technology that recognizes 10,000 objects moving around, right? That's an exercise for the reader, let's say. Drop my phone. So this is why I say that we are in a wonderful time. Absolutely, computer models are easy to fool. All models are easy to fool. No model is perfect. But this is something that we didn't have 5 years ago. So with even pretty simplistic models that will be fooled often, you can do things that are far more, that they are simpler to do than the crazy chaotic image that you saw. Like you can classify lemons or cucumbers. That is super easy, and it's not that difficult to make a model that has very high accuracy in those type of situations. How many companies are taking advantage of this? Not that many, or not as many as we could have. And there are many problems. There's a lot of low-hanging fruit that are there for somebody to pick. And right now, there are companies left and right, mostly startups, going for this low-hanging fruit. So it's my hope that I will convince more people to just go for these low-hanging fruits now before it's already picked. Okay, so some things that I've learned about training models, right? The biggest one is you can use pre-trained models. There's so much out there. You can download a model that is already pre-trained to do something pretty close to what you want to do, then cut the last layer of the network and stick a classifier on top and just save weeks of training. The big thing about this is that this helps with the point that I made before, that you don't need to be Google to train a model, right? Somebody must have trained a model already for weeks, and it's making it available for you to reuse. So please reuse models that are already pre-trained. Next. Okay, so another trick to do things that make people's eyebrows go up is take a paper, a good one from a good journal, that is doing something great for the field, but the people who wrote them are not machine learning people, right? Take biologists, right? I don't know if I should address the questions or just keep going. So I'm going to keep going, and maybe we do an open question answering at the end. So this happened at DSR already once. There was a team that wanted to do something with batteries, and they took a science paper where they predicted the charge-discharge pattern of a battery, and they could predict how long the battery would last. So this was a paper in Science, which is one of the two tier 1 journals in science, right? So the people writing the paper were not machine learners. They were applying random forest to this problem. And then the team that took this problem beat them by a big margin. I don't remember how much. So much so that Siemens offered them to just work on this six months longer they would pay a salary for the three of them, and they said no. So they had other things to do, and they did it. So this is a great trick. Just take a published paper in a discipline that is not machine learning, but is using machine learning, and basically beat them by having better models. Next, Nico. And of course, this is all that I've been saying so far, just reuse models that are out there. Okay, what is so? Something that you can see is not going to be state of the art, right? So if you look at the problem, you know the technology that there is, you get the feeling like, this could be improved, right? So for example, if somebody is applying, say, tree-based methods to images, right? You can say, well, I probably could do better with deep learning, right? Okay, next, Nico. Okay, so one thing that I've learned about training models is that there is not much theory. So there are rules of thumb of what to do training models in deep learning. There is nothing like what we have in science that has been accumulated over 200 years. There are some things that we know what we're doing, right? Not many, but we have some parts of science where we know that we can do well, right? We have ways to answer questions, right? This is not the case in machine learning right now. We basically try things and see what sticks. So even people who are very good at these learning models, they basically iterate a lot, and there are very few things that you know for a fact are going to work. You have to try them, right? It's kind of the no free lunch theorem and so on. Next, Nico. This is the best collection of such rules of thumb that I can think of. It's a book by Andrew Ng. That is, you can tell that this is just written by a practitioner. Yeah, the presentation we can post later on in the chat here. Yeah, there's a, excuse me, there's a Slack. So I will post a link to the presentation. Next. Okay, this is a big one. So when you train models, there's a risk that people lose trust in your model. I call this the gorilla problem. If the errors that your models make are super obvious, then that could destroy trust in them. This is what I call the gorilla problem. Next, Nico. You may remember that Google had, I think Google Photos at some point had a way to recognize objects and people and so on in them. And unfortunately, one of the photos, the model picked up a couple of African Americans and labeled them as gorillas. So as you can imagine, this was a PR disaster, and Google had to backpedal on this. So this is what I call the gorilla problem. One misclassification could ruin your model. People will not trust your model ever again. Another situation where this could happen is classifying fake news. So imagine that you have a model that is classifying fake news, and then I install the plugin and I'm reading news, and then I'm reading one journalist that I really like, and you tell me that this is fake news. I will go like, okay, this plugin is out of the window, right? It only takes one misclassification to ruin the entire experience. So this is what I try to not have in projects that people do at DSR. I try to avoid the gorilla problem at all costs. It's very easy to fail if your project has the gorilla problem. Next, Nico. Oh yeah, the book from Andrew Ng is free, which is awesome. So I already mentioned this, the idea of combining multiple models doing a single task, for example, the cigarette butt picking robot. Next. And here you have it, right? So there is a model for recognizing the cigarette butts. This is totally not rocket science. It's very easy to do, actually. There's a model that drives the car, towards the cigarette butts. And there's a model that picks up the cigarette butt, which it's a robotic arm, right? And that photo, that was still a Raspberry Pi. We used 4 of them. We burned sequentially 4 Raspberry Pis. It's really, hardware is really difficult. That's also one thing that I've learned. Everything fails a lot more than you would expect. If you are used to software, it's harder to iterate. So in a way, I don't recommend hardware projects. At the same time, they are so cool that you see things interacting with the real world and you feel kind of proud. Next, Nico. Okay, so there are people saying that winter is coming, that there's so much hype in AI. I partly agree. There is many things that are overhyped. But in my experience in the last 6 years doing projects at a pretty healthy pace, next, Nico, I think we are in a wonderful time to be alive. You can build things that were impossible 5 years ago and that solves real problems for real people. And I want more of this happening. So I want to encourage as many people as possible to build projects like this. Right. So, okay, and now we are back to the situation that how do you do this practically, right? So there's this cool data science retreat that you can do it and so on, but it's expensive. I know that most people don't have 12.5K that it costs right now to come to Berlin to do it, and some people cannot come to Berlin, period, because of Corona. So the one solution that we have is an income share agreement, which is a concept that I really like. I think it's one of the few things in social entrepreneurship and social impact that actually works for everybody. Like everybody makes money, it contributes to society. It's the idea that you only pay after you get a job. So we have a partner that offers this to us. So if we interview you and we accept you, they will give you this ISA, income share agreement it's called. So this is my way to get more people to do this. And unfortunately, here in Europe, it's not very popular. In the US, people get it immediately because they have this idea of education being expensive and people having ridiculous student loans and so on. In Europe, we don't have that because education is mostly free, right? But still, if you want the type of education that we provide, we have to get paid somehow. And this is the way that we found to make it kind of not a problem for you if you don't have the money up front. You only pay after you get a job. If you don't get a job that pays more than 27K, you pay nothing. If you stop your job for whatever reason, because you lose your job, because you want to study more, you want to do a PhD, whatever, then the repayment stops. And if 5 years elapse after you took the contract, then the contract dissolves as well. This is the idea of an ISA, which is to stop the downside of having to delay payment. Okay, so what does this mean? Next, Nico. So this is a little bit a stretch, right? Okay, so we have machines that can see, that can hear, that can read. Honestly, not very well so far, but the idea here is that machines are not just computers and phones. Machines are things that you can build with sensors that are cheap that you can attach to all these phones and computers and so on. What can you build with this next? So this is what I want to see, what you can build with these machines, right? And if you are thinking like, oh, by these Corona times, I don't know what's going to happen with the world. Next, Nico, this is the last slide. One more. Click. So you may think that you don't have options right now, that you're out of options. I make my own options, so this is what you can do. So change the environment around you completely.
Now we seem to be outside the place.
Stop, Nico.
In the moment.
So these guys are doing something like changing completely their environment. They were in a plane that was falling, and now they are falling without the plane, so it's a different environment. You make your own options, right? So this is what I want to see more of. I want to see people that are switching completely the game. And the game is, okay, there are no jobs. What the hell? I'm going to train myself into something that is not going to be affected by Corona. Or, oh, I cannot work remote, right? So this is what I want everybody to think. Okay, there is Corona times, we're in a plane, the plane may not be flying very well, we're falling. Look at the penguins from Madagascar. They completely changed their environment, and this is what we should be doing. So thank you for your attention. This is all that I have for you guys.